Hello, welcome to the video. In this lesson, we're going to be looking at section 11.2, where we're going to look at box and whisker plots. So, question here says, how can you use a box and whisker plot to describe a data set? So, first thing is, what does a box and whisker plot look like? Well, it looks something kind of like this. So right here is an example of a box and whisker plot. Now, again, looking at it right off the bat, you're like, what does all this mean? What are we trying to find for these for this kind of a diagram? Uh, Essentially, we are trying to find five numbers. Okay, it's a five-number summary in this particular diagram. So the first thing, actually the first two things, the first number you're going to look for is the smallest value or the least value in the data set and the greatest value in the data set. So that's one and that's two. And then the third thing you're going to look at is the median. All right. So we knew how to find median from the previous section. So those are three of the five values that we have to discover in order to find the order to, order to create our box and whisker plot. The next thing is something that's new is trying to find our first quartile and our third quartile. All right, those are essentially like medians, like almost like quarter medians. So and I'll show you what that looks like with the examples. And it's really it's basically trying to find the median, but it's trying to find like the quarter median in this sense. So what I want you to kind of take from these box and whisker plots is this. So whenever you see a box and whisker plot that's supposed to represent a data set, what it means is this. This first whisker here is going to represent 25% of the data. All right. This other whisker here is also going to represent 25% of the data. And then the box here is going to represent 50% of the data. So uh, that's what it's telling us in these particular diagrams. But in order to create these box and whisker plots, we need to find our five-number summary. Okay, so here they want us to make a box and whisker plot. My apologies. A box and whisker plot that represents the ages of the members of a backpacking expedition in the mountains. So these are all ages of people that are going to be going backpacking. We need to create this box and whisker plot. So what I'm going to do first is let's put all of these pieces of data in numerical order. So looks like the youngest person here is 18, so I'm going to put 18. I'll cross that out. Looks like 22. Cross that out. Looks like I think there's another 22. Cross that out. 24. Cross that out. Is there a 25? Yes, there is. Here, I think there's another 25. There, I think, oh, there's three 25s. Boom. All right. So, is there a 26? No. Is there a 27? Yes. 28. And looks like there's three people that are age 30. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So we got all the values, and we have them in order from least to greatest. So what I like to do is just like to circle my largest number and my smallest number. So I got those in there. So I know that that is going to be, all right, 2 of the 5 numbers that we need to find. The next thing we got to do is find the median. So what I'm going to do here, let's even make it a different color. So we said it was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to go 6. So 1, 2, 3, 4, 5, 6. So I'm going to do this, and then 1, 2, 3, 4, 5, 6. All right. So since it's an even number pieces of data to find the median, I have to take the two middle values. So it's 25, 25. This one's easy enough because they're the same value. So 25 plus 25 is 50. 50 divided by 2 is 25. So my median is 25. All right. Now, to find the other two values to find my first quartile and my third quartile, what I'm going to do is I'm going to look at these two individual boxes that I created, and I'm going to find the median of the two boxes. So since there's 6, so I got to split it right here in the middle. So I got to take 22 plus 24, divide that by 2 is going to be 23. And then I have I have to split it here between 28 and 30, add those together, divide it by 2, I get 29. So now I've found all 5 of my values in order to create this box and whisker plot. So again, so first thing we're going to do is, so I got 18, I go over here, I write down, all right, so there's 23, this is 29, and then so 30s are kind of right there, so I'm just going to make it pretty close to 29, and then 25 is, I'll just make it kind of right about there. And there is my box and whisker plot. All right, so I got my largest value, I got my first quartile, I got my median, got my third quartile, and my largest value. There is a box and whisker plot. Here, they gave us a box and whisker plot to look at. So it says, this box and whisker plot represents the length in seconds of the songs played by a rock band at a concert. So whatever song they played, that's how many seconds that particular song was. So first off, they say find and interpret the range of the data. So the range, if you recall from previous section, is you take the largest value, in this case is 300, and subtract it by the smallest value, which is 160. So my range is going to be 140 seconds. So that's my range. Here it says describe the distribution of the data. All right, so if you recall when I talked about um, looking at a box and whisker plot, this first whisker represents 25% of the data, this box represents 50%, and this box right here represents 25%. Okay, so being able to describe this with that set of 25, 50, and 25, we can go about and say, okay, 25% of the songs are going to be in between 160 seconds and 220 seconds. So that's the first thing. So I could say 25% of the songs will be 160 to 220 seconds. Next, we're going to be looking at what 50% is. So go back up to here. 50% of the songs are going to be between 220 seconds and 280 seconds. So And then finally, the last 25% of the data is going to be between 280 seconds and 300 seconds. And then part C, it says find and interpret the interquartile range of the data. So to find interquartile range, what you are going to do is you're going to be looking at, so I have my third and first quartile. All right. So my third quartile is 280 and my first quartile was 220. So to find my interquartile range, you just subtract the two, which then you get a value of 60. All right. So what is the interquartile range used for? Well, basically what we can say is this range, in this case being 60, this means that most that that the most of the songs are going to be plus or minus 60 seconds of the median. Okay. And then the final question says, are the data more spread out between or more spread out below quartile 1 or above quartile 3? And they're asking to explain. The answer, if by looking at it, is it's more spread out in below quartile 1, because you see how much longer this whisker is compared to this one. So we can make the conclusion by looking at the data that it's more spread out below Q1. And looking at the whiskers, there is some different descriptions that you can look at, or characteristics that you can look at when you're trying to identify these types of box and whisker plots. So an example here, so this one that I just underlined looks very similar to the box and whisker plot that we just looked at. That is considered, they could call it a skewed left, which means that the whisker is longer on the left side than it is on the right hand side. So it's talking about the whisker, not the box itself. If it's symmetrical, which means that both whiskers appear about the same length, and then a skewed right, which means is that the right whisker is much longer than the left whisker. So here again now we have two box and whisker plots. One is supposed to represent test scores for your class and your friend's class. So they have the data represented there, and it's asking you to identify the shape of each distribution. So if we were to look at your class, it looks like the left whisker is much larger than the right, so we could say that this is skewed left. And your friend's class, it looks pretty close to even, so I'm going to say that it is symmetric. And then it says, which test scores are more spread out? And they're asking to explain. So in order for us to figure out which ones are more spread out, you're going to kind of take a look at both the range and the interquartile range. So if you look at your class, the range, I would say, if you look at it, it's like 100, and it looks like it's between 65 and 70. So if we did like 67, so it's about 33. So the range we say is about 33 is exactly, I think it's pretty close. And then if we looked at the interquartile range of your class, it looks like it's what, 95 minus 85, which gets us 10. All right, so we have, so now your friend's class, if we try to look at the ranges here, looks like 160, so that looks like 40. And then interquartile range is 90 minus 70, which is 20. So in both instances, both the range and the interquartile range is larger than in your friend's class than your class. So I would say that your friend's class is more spread out because of the range and interquartile range being larger than your class. And that is being able to use box and whisker plots. Hope this helps. Till next time.